Hi guys, welcome to SchoolNut. I hope you're all safe. Thanks for liking and subscribing my previous video. And today we'll be looking at the sign convention for spherical mirrors and lenses. So I'll be starting off with the sign convention for spherical mirrors. As you can see, I've taken a concave mirror first. And this horizontal line passing through the pole of this mirror, the pole is the center of the mirror, it is called the principal axis. And here F is the principal focus. So at the principal focus, all the rays after reflection will emerge. They will all meet at one point. That is called the principal focus, right? So here AB is my object. A dash, B dash is my real and inverted image. So the main rule here is when you're measuring any distance in the direction of light. So here, as you can see here, this is the direction of light, because if you want to see an object, the object has to emit some light, right? Either from a source or something, right? So this object, the light rays from this object will be reflected onto the mirror. So this is the direction of light, right? Now, if you're taking any distance opposite to the direction of light, the distance will be negative, right? So let's say you want to measure the focal length of a concave mirror right here. So the focal length is the distance between P and F, right? The pole and the principal focus. So this is your F. So you want to measure F, the small f, right? So any distance you measure, you always measure it from the pole of the mirror, okay? And move towards the point that you require. So here, this is the pole of the mirror and this is the point you require. So you want to measure this distance. Now you're going to move from P to F. So since you're moving towards the left side, which is the opposite to the direction of light, the distance will be negative. So your F here, in this case, is negative for a concave mirror. Now, in case of a convex mirror, okay, your F will be here, right? Let's say F dash. Obviously, the shape of your mirror will change. So your F dash is here, and you want to measure the focal length of the convex mirror. So you move from P to the required point. So from P to F dash, right? So you're moving from P to the right and to F dash. So you're moving towards the right. So right here is the direction of light. So it is towards the direction of light. So your small f, that is your focal length here, let's say F again or F dash, whatever, is positive. Now how you can remember? Convex meaning positive and concave is negative. Here this is a silly rule, but convex has an X in it and it looks like a plus, right? So you can remember it as positive. So this is a major rule to remember. Now you want to measure the object distance. At what distance the object is from the mirror, right? So this is your object and this is your pole. Now you want to measure this distance, right? So let's say from P to B, you got to move towards the left, right? Which is the opposite to the direction of light. So you're moving towards the left. So this will be your U, your object distance being negative because you're moving towards the left, right? Now you want to measure the image distance. Your image here is the blue arrow mark here. Now again from P, you're moving towards the image, right? You're moving towards the left to B dash. So this will be your image distance, that is V. This will be again negative, okay? So both your object and image distance will be negative. Now, the object is erect and upright. So whenever anything is erect with respect to the object, So you're taking object here first. So your object is erect. So the height of your object, h, will be positive. Now again, this is a rule. Now your image is inverted. With respect to what? With respect to your object, right? So your image is inverted with respect to the object right here. So the height of this is h dash, and this will be negative. So whatever is inverted with respect to the object will be negative, right? So let's say you have here, let's say you have a convex mirror, right? So this is your convex mirror and this is your object, and you will get a virtual image here, right? So here your object height is positive, and again the image is not inverted with respect to the object. So your h dash, that is your image height, is also positive, okay? So you have to do it with respect to object, just remember that. And whatever problems you solve, you have to draw the diagram first. It doesn't have to be understandable to anyone at first, initially, while practicing. As you go, you can draw it according to the rules that they said. So that's all for spherical mirrors. Now let's go to lenses. So for a lens, again, so here I've drawn a convex lens, right? So it will be the same for a mirror, okay? But the major difference is you're measuring all the distances from the optical center of the lens. It's not the pole. Pole is for spherical mirrors. So for lenses, you use optical centers. So now again you want to measure the object distance from the lens, okay? So that will be your U. So you're measuring it from O to the object. So you're again moving towards the lens. Again, this is the direction of light, right? Because from the object, the light will be emerging. So your U, the object distance, will be negative because from O you're moving towards the left. And this is your image. And your image distance V will be positive because it's on the other side of the mirror. You're moving from O to the image towards right in the direction of light, correct? So your V will be positive, right? But one thing remains the same. For a convex lens and mirror, the focal length, right? The focal length will be positive. And for a concave lens and mirror, your focal length will be negative. As I told you, X is like a plus, so it's positive. That way you can remember it. So that's the major difference between a spherical mirror and a lens. I hope you liked it. And if you have any more questions or you want more explanations or you want any solution to problems, just mail me or just type in the comment box below and I'll be right here to help you. Stay safe guys. Goodbye.